Dear student, myself Srijan Banerjee, Assistant Professor, Department of Electrical Engineering of Gargi Memorial Institute of Technology. Hope you are all sound health in this situation. Okay, today I will discuss that how we can design a state variable model of a physical system. We can see various kind of physical system in the universe. So that those systems are basically of electrical, electronics, mechanical, hydraulic, the combination of electrical and electronics, and this kind of things. So among those physical systems, we are considering mainly five systems for this case, for these tutorial sessions. Number one, spring mass damper system. Number two, electrical networks. Number three, electromechanical system, that is DC servomotor. Number four, heat transfer system. And number five, liquid level control system. First, we discuss about spring mass damper system. The spring mass damper system is basically a mechanical system, and it is a combination of a spring, mass, and damper or some shocker. In the above figure, we can see the block diagram of spring mass damper system, where the M block is the mass and B is the damper. In figure 2, we can see the free body diagram of the spring mass damper system. In the free body diagram, we can see that there will be three forces will acting on the block M. One is F, that is the force, another is B x dot due to the damping constant, and another is for the spring, that is Kx. So here we can see that if the force F is equal to B x dot plus Kx, where x is the displacement of. So from the block diagram we can derive the second order differential equation, that is M into d2f dt2 plus B df dt plus kf is equal to 0. So here if we assume that F force is a state x1, then F dot equals to x1 dot, that is equals to x2. So if we put these state conditions in the differential equation, then we will got the state equation, that is x dot, and the output equation is y, that is equals to 1 0 x dot. Electrical networks. Electrical network is basically the combination of resistor, inductor, capacitor, these three circuit elements, and the source. The source is maybe voltage source or current source. So in these components we can connect or we can make the circuit in two ways. One is series circuit and another is parallel circuit. In this figure we are considering our RLC series circuit, where the voltage source is V, a DC voltage source, and the current throughout the circuit is suppose IA. So for this case, if we write the mathematical equation of this system, then we can write Vt minus Ri minus L di dt minus 1 by C integrate I dt is equal to 0. So the state variable we are assuming that x is equal to Qi, where Q is the charge and the relations with the current is integration of I dt. So from this equation, from the mathematical equation, we can derive or we can achieve the state equation, that is x dot, and the output equation, that is y. So if we want to find out the transfer function of that system, then we can easily write down by using the transformation rules from state space to transfer function, that is Is by Vs is equal to C into Si minus A inverse into B plus D. electromechanical system. Mainly we are discuss about DC servo motor. Actually, we know that the motor is basically a combination of electrical and mechanical system. In a motor, if we give the electrical supply or electrical energy in as input, then we will get the mechanical energy as output. And in the DC servo motor, basically we can control by two way. One is armature voltage control and another is field current control. So this is the basic circuit diagram of a DC servo motor, where V is the source, RA is the armature resistance, LA is the inductance of the armature winding, and in the motor there will be torque T. So from this diagram we can derive two equation. One is electrical equation and another is mechanical equation. So from these two equation is basically nothing but the correlated with each other for the machine or for the DC servo motor. And from these two equation we will get the state equation. One is x1 dot and another is x2 dot, and the output equation is just related with the yt is equal to x2t. As we know that in motor the output we will get the output the mechanical energy. So as we are assuming that the state of the output equation or the mechanical equation is x2, that's why the output equation yt is just related with the state equation x2. And from this state equation we will get the system matrix A, B and C. Heat transfer system. This is a very important thing for the mechanical engineers and as well as electrical engineer. The heat transfer concept is basically required for the refrigeration system and for the cooling system. So in case of heat transfer system we have to very much aware about the total amount of heat storage in a system. So here in this figure we are considering a basic fundamental heat transfer system where from the input channel the steam is coming into the system and there will be an output channel. So for this system the heat balance equation is rate of heat storage is equal to rate of input heat minus rate of output heat. So for this system we can write the heat balance equation for three systems. One is for radiator, and another is for the room air, and another will be room wall. So from these three equations we can derive the state equation of the liquid level control system. This kind of system is very complicated and very important. This kind of system is dependent upon various parameters such as the what kind of liquid is used for this kind of system. Number 2, the shape of the tank. Number 3, how many tank is interconnected with each other. So there are various kind of parameters or various kind of aspect is used or is dependent to control this kind of system. Here we just assume two rectangular tank, and the volume of these two tank is different. So here we can see that tank 1 and tank 2, tank 1 is bigger and tank 2 is smaller than that, and this two tank is interconnected with a channel or with a connector. So for this case we have to derive the equation of the level for tank 1 and then for tank 2. So we already derive here for tank 1 we can write the equation is rho into A1 into dx1 dt is equal to rho into u minus q1. A1 is the area of the tank 1 and x1 is the state of tank for tank 1 and rho is the density of the material, and u is u is the input and q1 is the intermediate output. So same thing we can derive for the for tank 2, where A2 is the area of the tank 2, so rho into A2 is equal into dx2 dt is equal to rho into x1 minus x2 by r1 into g minus rho into x2 g divided by r2. So from these two equation we can derive the state equation of this two rectangular interconnected tank system.